If you haven't done so yet, make sure you pause the video and try to answer the question first on your own before listening on. The first step in determining the volume of this solid is to sketch the graphs of the two given curves. So here is the sketch of those two curves. We've color-coded them, so the graph of x equals 2 minus y squared is portrayed in red, as you can see by this sideways parabola. And then the graph of x equals y to the fourth is portrayed in orange, which is also a sideways opening curve, though it's not a parabola per se. If you had any trouble graphing those two curves, one method you could employ is making a table for each curve. Normally when we make a table, we select x values and then plug them in. But because these equations are solved for x, we actually want to plug in y values into the table. So for example, for the first curve, we could select some essentially random values of y. So for example, if we made y 0, we would plug 0 in here. We would have 2 minus 0 squared, which comes out to 2. So the point 2 comma 0 should be on this red curve, and indeed it is right there. And then you can continue making up some values. So another good value would be 2 for y. And if you plug 2 in for y, you're going to have 2 minus 2 squared, which comes out to negative 2. So the point negative 2, 2 should be on the curve, and indeed it is. So you can continue to pick points, and that would allow you to map out the red curve. A similar scenario would apply for the orange curve. So again, you could make up 0 for y, plug it in, you would get 0 for x. So that point 0, 0 is indeed on the curve. You could make y 1, and if you plugged 1 in here, you're going to get 1. If you plugged in negative 1 for y, you'd also get 1. So those 2 points should be on the curve, and indeed they are. So that would just be one admittedly crude way of graphing those two curves. Now that we have the curves graphed, what we want to do is consider that we're revolving this purple region that the two graphs enclose about the y-axis. And it's usually a good idea to draw a reflection of this region over the axis that you are revolving around. So in other words, since we're revolving around the y-axis, we're going to draw a reflection across the y-axis of this region right here. And so there is the reflection, or at least an attempt at drawing a reflection over the y-axis. The key is to notice that there is what I would call white space between the two shaded regions. You've got the shaded region on the right and the shaded region on the left, and there's a sort of white space between them in this area right here, and then also down right here. Now, whenever you have this white space or this empty space between the two shaded regions, you're going to need to use the volume by washers method in order to find the volume of the solid. Let's look at the formula for the volume by washers. So here is the volume equation for washers, and you'll notice that we are writing the equation with dy, and the reason for that is because we are revolving about the y-axis. If we had been revolving about the x-axis, then we would use dx. But again, in this case, we'll be using dy. Now, what we need to figure out is the so-called outer radius and the so-called inner radius. And a lot of professors will try to draw out some cylinders in order to represent that, but the drawings usually get kind of cluttered. So I want to take a somewhat more simplistic approach. And what I'll do is I'll pick a point along this curve that is located farther to the right than the other curve. So that would be this red sideways opening parabola. I'll mark a point on that curve, and I'll draw a line over to the axis that I am revolving around, which in this case is the y-axis. So that would be what we're calling the outer radius right there. And we can see that that distance is a horizontal distance, and because it's horizontal, it's actually an x distance. So technically, the outer radius could be represented as x. The problem with calling it x is that we are integrating with respect to y. And so we can't come in here and say x for the outer radius and then try to integrate with respect to y, because that's essentially an inconsistency in the variables. But luckily for that sideways opening parabola, we know that x is 2 minus y squared. So what we can do for the outer radius is plug in 2 minus y squared. For the inner radius, we'll take a similar approach. We'll mark a point somewhere along that curve that we had represented in an orange color, so perhaps right here. We'll draw a distance to the axis that we're revolving around, which again is the y-axis, and that distance right there, because it's horizontal, is also an x value. And we know that for that orange curve, x was equal to y to the fourth. So in short, the inner radius is going to be y raised to the power of 4. So now the only thing that we are missing is the value of c and d. Now c is going to be the smaller y value where the curves are intersecting. So go back and see where the curves are intersecting, and you'll see this point right here. That's going to represent what we're calling c. Remember that it has to be the y value. And then the larger y value where the curves are intersecting is what we're calling d. Now we can actually see from the graphs that c is going to be -1 and d is going to be +1. However, if your professor expected you to show that algebraically, what you could do is take the two expressions for the curves, so 2 minus y squared and y to the 4th, and set them equal to one another, and then try to solve for y. So we'll do that briefly. We'll add y squared and subtract 2 over to the right-hand side. And then it looks like this equation actually factors. So we're going to end up with y squared plus 2 and y squared minus 1. And since it's set equal to 0, we will set each factor equal to 0. For the first equation, if we subtracted 2, we would see that y squared equals -2, but that doesn't have any real solutions. If we added 1 over to this side, we have y squared equals 1. And if we square rooted both sides, we would see that indeed y could be either +1 or -1. And that is what we had concluded graphically. So we'll come over here and replace c with a -1 and then replace d with a +1. And then we're going to try to simplify and integrate. Now to square out 2 minus y squared, we would have to write it out twice, and then we're going to FOIL it. And then to square y to the 4th, we recall that when we have a power raised to another power, we simply multiply those powers. So 4 multiplied by 2 makes 8. We'll FOIL out the 2 minus y squared. And there are no like terms here, so we can't combine any of them. The pi is a constant, so that can be factored out of the integral. In fact, I don't remember if in the beginning of the video I put that pi on the outside of the integral to begin with. I might have, but we can always keep that pi on the outside of the integral. Now we're going to go ahead and integrate. So the integral of 4 with respect to y will become 4y. For the next term, what we're going to do is add 1 to the exponent and then divide it by that new exponent. So 2 plus 1 here is going to be 3, and then we'll end up dividing by 3 as well. So we'll have 4y raised to the 3 over 3. Same thing with the next term. We'll have y to the 5th over 5. And then again, we'll add 1 to make y to the 9th and then divide by 9. We have our lower and upper limits of integration. We plug the upper limit in first for all of the y's. Unfortunately, there's several of them. And then we're going to plug in the -1 in for all the y's. And then we'll subtract those results. So there are the limits of integration plugged in. And we've enclosed the first cluster of terms in brackets right there, and then the next cluster of terms in brackets right there. Be careful to do that because this minus sign right here must distribute to all of the terms in the second cluster of terms. So you can carefully type that into a calculator, and when you do so, you should get 248 over 45, and then we have this factor of pi remaining as well. So we'll tack that on, and this becomes the final answer.